Today we are going to be going back into our warm-up. Yesterday we were talking a little bit about area and circumference of circles. So I want us to be working on the warm-up. Remember, our goal for the review sessions is students will build on the past notes and knowledge to succeed on their final exam. Let me minimize this so you guys can see the warm-up. So go ahead, I passed you out a worksheet. Go ahead and start working on solving for the areas of both that circle and that rectangle. I'm going to give us 3 minutes because I want to conserve some time for our other skills. 3 minutes, folks.
Going back there.
Yeah, this one will help us with it. At least for the first one. Yeah. What are you figuring?
Can I go to the bathroom real quick?
It's 10 minutes past. Yeah. So shall I try to finish now, Armand? Did you just take one? Not me.
Yeah.
Yeah. All right, so let's go ahead and let's go over the warm-up, starting with A. Number A, do I have any volunteers?
The radius is 5.
The radius is 5, so we know what the radius is. And how do we use that information?
The radius is 5, but because A equals 5, and this is 5 squared root.
5 times pi. 5 pi times 5 squared. And then when we type that in, what do we get?
25.
25 times pi, so it'll just stay as 25. Sweet. Any questions on how we did number 1 or part A? All right, going over to part B. Do I have a volunteer for part B? The area of that rectangle?
The area?
Yeah, just the area.
We 4 times 3.
4 times 3. So if we remember for our area, this is our length, this is our width. For the area, it's just length times width.
Really?
So it's 4 times 3. And then what does that equal?
Good. It's backwards.
Huh?
It's backwards.
What do you mean it's backwards?
Isn't the length supposed to be on the side? And the width's supposed to be on the top?
Doesn't really matter, to be honest. For this, it doesn't matter. You can interchange anything with it. Like it can be base times height too. That's another way that it's read. But good question. Is this 12 complete yet? What am I missing?
Inches.
Inches. How many dimensions do I have? 2. So it should be inches squared. Remember that dimensions and knowing how many dimensions in this shape is going to be super important as we go along with everything. So, all right. This is where we left off from yesterday. So, now we need to talk a little bit about volume and surface area of 3D shapes. We're going to start off with spheres. So spheres, again, that's just a circle that's rotating so fast that it makes a ball-like shape. So if you need to give yourself an example of what a sphere should look like, maybe label it. Pick a sport or an item that you like to play. If you like to play basketball, sphere is just a basketball. If there's something else that you want to think about it as, baseball, tennis ball, something other than a ball, those are the only examples I can come up with right now. But, reminder, this is the idea for volume, this is the idea for surface area. Both of these are equations that we're going to use. Just like with circles, what's the one thing that we need to find? What's our only variable in there?
Radius.
R, radius. So in order to find this, you're going to need the radius. So for both of those, that's the only thing that really sticks out that we need to solve for, right? So let's look at example number 1. For example number 1, we're trying to solve for the volume and the surface area when R is 3. If we look, R is 3, so in this equation, we're just replacing R with that 3. The 4 over 3 pi doesn't change, and the exponent to the power of 3 doesn't change either. All that changes is the variable, because we figured out that the variable of R was equal to 3. So we plug in a 3. Then we just do our steps, our normal order of operations, right? Start with our exponents, because there's nothing inside parentheses that needs to be added or subtracted. So we'll start with our parentheses. So 3 squared, this is the color that I want. Sorry, 3 cubed is 3 times 3 times 3, which gives us 27. So that's how we get from 3 cubed to 27. Then, what we want to do is we're just focusing on our 2 whole numbers, or our 2 real numbers, our rational numbers. This 4 over 3 and this 27. Those are the 2 that we're going to combine because, yes?
For every one of those questions, is that the only thing that's going to get taken away?
For all the sphere questions?
Yeah.
Yeah, that's the only thing that's going to be changed. So for spheres and for circles, R is the only thing that's involved with it, so those are the only thing that's going to change. Good question. So we multiply these 2 together, so it becomes 4 over 3 times 27 times pi. When we multiply these out, this becomes 90.
I can't see after.
What can't you see?
I couldn't see the other.
Okay. That becomes 4 times 3 times pi. I know I'm going over this. I'm going to slowly just erase some of those things after we get that done. Now 4 times 27, what does that give me?
108.
108. So we have 108 pi divided by 3, and can 108 be divided by 3?
No. 36.
36. So that's how we get our volume of being just 36 pi units cubed. Remember, if I don't give you a units, just use a U on the test, okay? So if there's no specific units, like it doesn't say inches, centimeters, meters, kilometers, miles, etc., you'll see a U next to it. U just stands for units. So don't freak out when you see that on your multiple choice final, okay? So you might want to actually write this down so you know when you see U, it means units. Now going along the surface area, just like JV said, the only thing that we're replacing again is the R, because that's the only variable that's in there. So we still use that same 3, and we just plug it in where R was. And then, same thing, go through our order of operations. There's nothing inside the parentheses to simplify, so we go to our exponents. 3 squared is just 3 times 3. 3 times 3 is 9.
Can you see that other hand?
So 3 times 3 is 9, and that's where we get this 9 from. Then again, multiply those numbers that we know. 9 times 4, 36. And that's how we get 36 pi. And for surface area, our units are squared. I think it was on Tuesday when I drank the water bottle, cut it open, and showed you guys what surface area was. Because it turns into a 2D shape, that's why the units are squared. But do we have any questions on that?
No.
All right, so you guys are going to have 1 minute now. For example number 2, solve for the volume with the surface area, or solve for the volume and the surface area when R equals 9. I just want you to set up the equation. What should both the surface area equation be, and what should the volume equation be? You have a minute. Go. Raise your hand if you need. If you still need to catch up on those notes, catch those up, because I'm going to delete it and move on. Yeah. So all we're doing is
Are you supposed to be taking notes?
so what equation?
Fine.
Huh? Yeah. Equation's correct. So then write the other one for surface area. Don't worry about solving it yet. No grab. Alright, give me 1 second. Yeah.
Halfway.
Okay. All right. Did anyone come up with an equation? I'm just going to write them right here because I don't want us to lose these notes yet. Did anyone come up with an equation for it? What's the first one?
430 pi parentheses 9 squared 3.
Squared, you said?
3.
And then what's at the end? Oh, did you say pi in there?
Yeah.
Okay. Probably do it like that. So 4 over 3 pi, 9 cubed. Or 9 to the power of 3, right? Good. Did someone get one for surface area? Anyone get an equation for surface area?
4 pi squared 2.
4 pi 9 squared, or 4 pi 9 to the power of 2? Good. Yeah, so that's it. Once you get this, a next step would just be to make it look like this in your calculator. And then at the end, whatever you get right there, throw on that pi, put in your units, and put it in the cubes, if we're talking about volume. Surface area, rearrange it a little bit. 4 parentheses 9 squared. Whatever you get in your calculator, just throw it in that box, give it a pi, and a unit squared. That's it. All right. Anyone still need these notes? Next, rectangular prism. All right, so our rectangular prism. Rectangular prism is just a rectangle stretched out. Remember, we're taking it from 2 dimensions, adding that third dimension, and just pulling it out. So since we added that third dimension, we need to add a third variable that we're going to multiply it to. So if we remember from the warm-up, our area was just length and width. Since the volume needs to be extended out a little bit more, we're going to put in that third dimension of height. So that's just the third thing that we did. And it's units squared. So if we look at our example for number 1, we're given the length, width, and height of a triangle. Or sorry, not triangle, a rectangular prism. For here, it's 4, 5, and 7. So under length, I'm just saying it's 4 inches. Under width, it's 5 inches. And height is 7 inches. It was brought up before during the warm-up. Does it matter what's given what? It really doesn't matter for this case. With multiplying, it doesn't matter if you want to say that 7 is the height, or sorry, 7 is the width, 5 is the length, and 4 is the height or the width, whatever. However you want to do it, but these 3 numbers need to be classified separately. One has to be designated the length, one has to be designated the width, and one has to be designated the height. But it doesn't matter. So from there, we just throw it into a formula for our volume. 4 inches times 5 inches times 7 inches. Put it into our calculator. 4 times 5 times 7.
140.
That's how we get the 140. And then I want you guys to think of this. We know that this fact is this, right? You remember that? Thumbs up for yes, thumbs out for no. We remember that fact? X times x is x cubed. Units work the same way. So if I have inches times inches times inches, how many inches do I have? 3. So it's just inches cubed. And that's where I get the units squared, units cubed from. Because we're just multiplying the specific unit together over and over again. All right, you guys should have the second example. If you're still writing this down, keep getting the notes. If not, start getting onto that next example. We got a little bit less time in class than usual. Let's get this frozen.
You could sneeze like that, it's so recorded.
Yeah, so that second example, if you flip your page over, it's on the back of it. And just so you guys know, we're going to actually move rectangular pyramids to Monday. So we're going to, if you can just identify the length, width, and height for that, so that we can make sure that we get through everything. But the rectangular pyramids are very similar to what we've been going over before, so we can touch on that in the morning, on Monday. All right. Someone tell me the length, width, and height. Length is?
7.
Width is?
3.
So then height would be?
3.
You used 3 already.
5?
Yes.
Wait, the height is 5?
So, that brings me back to my last point. It doesn't matter how you originated.
Oh.
He might have given something different than you did.
Uh-huh.
But, as long as you have it with what you have it as.
Okay.
You might have said 7, 3, then 5, but you had it as 7, 5, 3. That's probably what threw her off. All right, so let's talk about our next one, our writing equations for graphs. Let's make this go a little bit shorter. So let's go to that next page where we're talking about writing equations for graphs. Let's remember the steps for them. Step number 1, use the shape to graph. The shape of the graph to identify the base equation and the locator point. If it's x squared, or we have the a times x minus h squared plus k, who remembers the shape? Who can tell me Soldier Boy's favorite letter? U. There we go.
You.
That's our U shape. That's our parabola. Next, y equals a times the absolute value of x minus h plus k. What shape is that? V. That's the V. Once you identify the shape, that gives you this base equation. From there, the locator point. Where do I find the locator point on the U? Where do I find the locator point on the U? In the bottom, middle, yeah, right dab in the middle of this. That's where I'll find that. Next, where do I find the locator point on the V?
Bottom middle.
Bottom middle. What if it's negative? Where would I find it? How do we know if it's negative?
If it's upside down.
Yeah.
If it's upside down, so if Jaws is eating the fishies, bad movie. Jaws is eating the people, that's good. Jaws is eating the fishies, no Finding Nemo, that's bad. But yeah, we would find it at the top if it was negative. You remember that fact? So once you have your base equation, once you choose a locator point, next, there's 2 different options. If you have your x squared, we need a second point. Why do we need a second point? Because let's say this is our locator point. Locator point is 1, 2. We start setting up our equation. A is equal to x minus 1 squared plus k. Oh, we already know k? We said k was 2. So we have a times x minus 1 squared plus 2.
I can see.
What are we missing from there? What do we still need to know?
What, like,
Third dimension.
What a is, right? X and y we could find on the graph for any point that's on there. But we don't know what a is yet. So that's where we go to our second step of choosing a second point. So you look on your graph. If you see right here, and it's on your paper too, you should be able to identify what a second point would be.
-2, 0.
-2, 0. Now this isn't the specific one for it, but we'll use that second point. So we have our locator point and we have that second point. We'll use that second point. We'll use that second point to help us solve for a. Yeah.
Could you use the second point, -6, 0?
Yeah, 100%. As long as it meets what criteria?
It's on the line.
It's on the line, it's on the function, and it's easy, right? If I looked at this one and said, ooh, that looks fun. Do I know what that is? No, it's like a weird decimal, and do we want to deal with weird decimals? No. So pick a point that's easy and that's fun, that's on the function. So we pick that second point, we'll find a value for x, we'll find a value for y. If it's an absolute value function, do we need to solve for a?
No.
What do we use?
Forgot.
Go to where is step 3 and read right underneath that.
For absolute value functions, A is the slope of the line on the right side.
We use the slope of the function on the right side. So what? Do we remember how to identify slope?
So you gotta first see if it's negative or positive.
We'll check if it's negative or positive. How do we know if it's negative?
You're showing the equation.
Yeah, if it's going down or if it's going up.
Yeah.
What's another way that you can figure out slope? How did we learn it in IM1? Y-intercept, but what was the part before the y-intercept?
Before the y-intercept. Wait.
I think you're thinking slope-intercept form, right? Y equals mx plus b?
Yeah.
Yeah, so we know the b, but we're trying to figure out the m. How do we figure out the m?
Rise over run.
Rise over run.
Yes.
So if I pointed to you, Steve Austin,
Yes.
and said rise, what are you going to do?
Get up.
Get up, right? You're going to move
Oh.
vertically. So our rise is our change going up and down. And if I told you to run, which way would we move?
Left
Right.
Left to right, horizontally. And then a way that you'll see it on the internets, on the interwebs, change of y over change of x.
Yes, it does.
So change of y over change of x. That's the second way. So take a look at example number 1. For example number 1, let's look at the absolute value. You guys ready for me to change it over?
Yeah.
5 seconds.
So we go through our base equation.
You want